Now, let's say you want to extend the PassManager. You are not satisfied with all the internal PassManagers available. So recently I introduced Loop PassManager, so we'll just take an example. Before I introduced Loop PassManager, all the loop transformations are operated at the function level. So they will take a function, apply loop, let's say loop unrolling, then it will try to apply loop unrolling on all the loops in the function before moving on to the next loop transformation. Whereas what we wanted to do is that we walk the loop nest, take the innermost loop, apply loop unrolling, apply loop rotation, and all other loop transformations before moving on to the outer loop. So for that purpose, we introduced the Loop PassManager, and it was very easy to do. I wrote the Loop PassManager class, and it has the most important function is that it will operate on a function. Loop PassManager will construct the loop nest and walk the loop nest, and it will invoke each loop transformation one by one on a given loop. So that is simple. And I needed to create a loop base class that is used by all the loop transformations. And that base class is also very simple. It has one important function, assign PassManager. This is important because when user requests a particular pass to be executed, the external PassManagers don't ask various PassManagers to manage this pass. It's the other way around. We ask each pass to say, who is your manager? Find it. So this is done here. So here loop pass will see if there is an active instance of loop PassManager. If there is one, then it will assign it to itself. If not, then we'll create a new one and then assign it to itself. The reason why we do is that it helps us to achieve two goals. Number one is that LLVM is a collection of libraries. PassManager is part of the core libraries. But if you want to extend the PassManager, then you may not want to extend the core library. So you should be able to add your own PassManagers that are not part of the core library. And with this interface, you can do it. Second thing is that sometimes some of the passes would prefer one PassManager, but they are willing to be operated by another PassManager. For example, function level date code elimination. It's okay that it's expected that function PassManager manage that pass, but if call graph PassManager is available, then it makes sense that call graph PassManager use the call graph walk method to invoke this optimization pass. So summary, well, I went very fast, I know. PassManager plays a very important role in making LLVM very flexible and easy to extend. And its goal is to make your life easier. And we have more information about how to write an LLVM pass in the future. That's it.
That's a good question, Tom. Why does the PassManager API expose two different top-level-based classes, the PassManager and then function PassManager? Why can't they just work with the PassManager?
The reason that sometimes LLVM in cheat mode, the runtime system only want to supply a function with the path LLVM. So like, okay, go optimize the function or just go and turn in the code for function. So we need the capability to just operate on the function level. And then by providing a function level interface, we are explicitly eliminating any chance of using a module level optimization or etc. We are just limiting that you can operate only on this function interface. Does this make sense?
So if I wanted to generate code for an entire module, right now that passes the commit code, whatever it's called, only accepts the function PassManager, and then I've got a module PassManager. I have to somehow adapt it.
That should work because I don't recall the details, but LC takes a module pass, I thought. Maybe there's some weird.
In the LLC command?
Yeah, the LLC command line tool, I don't remember exactly the details of how it sets up the PassManager, but it's running the entire file through the PassManagers. I'm not sure. But in general, Deveng's right. It's because the JIT wants to be able to say, just JIT this one function, don't JIT everything. And so that's where it came into existence. The code generator as a whole is generally a function at a time, but there are exceptions, of course. So if you have a specific problem, then we can talk about that at lunch or something also. If you brought your laptop, we can fix it now.
So I think it's a nice abstraction, but have you experienced that this abstraction gets into the way of certain things, like conveying information from one place to the other, or is it the perfect solution which you can envision?
Can you talk a little bit about how analysis information is shared?
How information is shared?
Yeah. So dominators or loop info or something like that.
But in my example, I showed that whenever global one path moves the dominant information, if it's not available, then PassManager will automatically request that okay, generate the dominant information. What I didn't show here is that if there is a subsequent pass that use that information, then PassManager will not regenerate them and it will reuse them. And so, is that what?
Yeah, I mean, I understand the abstraction. Just in your experience, do you?
Oh, okay.
There come people to you and say, "Man, you need to extend this PassManager because I can't get A to B or whatever."
I think until now it is working pretty well. And in 1.9 LLVM release, the design was same, but the implementation was making life a little bit difficult to extend the PassManager. And so we have an implementation. And the only reason we wanted to extend is that we wanted to introduce the loop PassManager. But if you see this, we have covered most of the basic program level concept that you usually want to operate. So you may not want to extend it, but people like to do weird things.
So in general, I think it's worked actually really well. One of the interesting things about the PassManager is it's not trying to replace the need to do iteration over the program elements. So the point of loop PassManager isn't to make say loop transformation doesn't have to walk the loop tree. It's really about changing the sequence of optimizations and because we want to execute all the loop transformations on the inner loop before we move out to the next loop out. Right? That's the kind of thing that requires extending PassManager. What Deveng didn't say is that there's probably 60 function passes or something, right? So I mean, almost everybody gets through without any problem just using the normal stuff. It works fine. All the crazy interprocedural people want to use module passes, for example, and operate on the whole thing at a time, and that works great. Do you want to talk about the function pass, module pass requiring thing you added also? Or function passes can be required by module passes and what that means?
This is something that new in 2.0. Where now, if you are working on an interprocedural level and you are operating on a module, but then sometimes you want a function level information that is implemented by some external pass, for example, dominant information. And now you can request that also, like, okay, I'm operating on entire module, but right now I'm working on this function foo, and just give me the dominant information for function foo. Now PassManager can do that also. Until now, there was no choice because of the limitation of the implementation. But if we don't have that functionality, then the only alternative you have is that while working on procedural optimization, you develop your homegrown dominant information analysis for whatever component you want.
So did the PassManager decide when you tell the PassManager to run the pass? And you mentioned that if it is some information that available, such as dominator tree is not there, you automatically invoke a pass to change the dominator tree and pass it on. You also mentioned that if it decides that the information to a pass is not consistent, you also run it.
Yes.
How do you decide if an information is not consistent to a pass?
That is, each pass will have a chance to say